this lecture I will explain what is the need for modulation or advantages of modulation and also the amplitude modulation. So what is modulation, what is the advantage of modulation, what is amplitude modulation, demodulation, some examples I will explain. First of all, what is modulation? In the modulation process, some characteristic, the high frequency carrier signal, that is we can also call as bandpass signal, is changed according to the instantaneous amplitude of the information signal or baseband signal. So this is the definition of a modulation. So some characteristics of high frequency carrier signal is changed according to the instantaneous amplitude of the information signal. That characteristic may be amplitude, frequency or phase. That are the different types of modulations, what we generally call as amplitude modulation, frequency modulation and phase modulation. So next, before that, going to deeply what is amplitude modulation, I will explain the need for modulation or the advantages of modulation. Why we are going for modulation, why we are not directly transmitting the message signal. The first basic advantage of modulation is reduction in the height of antenna. If you directly transmit the message signal, which is a low frequency signal, then what happens is the height of the antenna will be impractical. We cannot design such a height of antenna, as for transmission of radio signals, antenna height must be a multiple of lambda by 4, where lambda is the wavelength and lambda is equal to c by f, where c is the velocity of light and f is the frequency of signal to be transmitted. So while calculating the minimum antenna height, the height will be very large when the frequency of the message signal is very less, as it comes to the denominator. So that is the main reason to make the height of the antenna practical. So if you make the message signal to high frequency signal, as that what we are doing in modulation with the help of, by taking the help of carrier signal, we are making the low frequency signal to the high frequency signal, then the height of the antenna is becoming practical. That is the main reason for the modulation. Next, avoiding the mixing of signals. If baseband signals are transmitted without using modulation by more than one transmitter, then all signals will be in the same frequency range, that is 0 to 20 kHz. Then all signals get mixed together and receiver cannot separate them from each other. Hence, if each baseband signal is used to modulate a different carrier, then they will occupy different slots under frequency domain, that is different channels. Thus we say modulation avoids mixing of signals, then it also increases the range of communication, as we are taking the help of high frequency carrier signal. So multiplexing is also possible. So what is a multiplexing is nothing but it allows the same channel to be used by many signals, or different frequency signals can be transmitted at the same time. So, and the other one is improves quality of reception. With FM and digital communication techniques such as PCM, pulse code modulation, effect of noise is reduced to a great extent. Like this, there are many advantages with the modulation. About modulation, the application examples are such as broadcasting of both audio and video signals, mobile radio communication such as cell phone. So basic modulation types, as I told earlier, when the carrier of the amplitude of the carrier wave is varied in accordance with the message signal, then we are calling it as amplitude modulation. When the frequency of the carrier is varied in accordance with the message signal, we are calling as frequency modulation. And when the phase of the carrier wave is varied in accordance with the message signal, we are calling it as phase modulation. So this is the example of amplitude modulation and demodulation. Here we are applying the baseband signal frequency to a modulator, which is simple multiplier. Here we are multiplying with the carrier frequency and we are getting the bandpass signal. Frequency is what we call as amplitude modulated signal with frequency Fc. This is the form of the amplitude modulation, what we call as AM modulation. And when it is applied to the demodulator at the receiver, this is at the transmitter side. This is when it is passed to the channel, we are getting AM modulation. And again, when it is passed to demodulator at the receiver to receive the message signal, we are passing it to the demodulator and we are getting the original signal with frequency FM. So the voice frequency is 300 Hz, just 3.4 kHz. And the GSM cell phone frequency is 900 MHz to 1800 MHz. So the amplitude of high carrier signal, which is varied in accordance with the modulating or message signal, is called as amplitude modulation. For example, if you take the carrier signal as cos 2 pi fct or cos omega ct, and the message signal or modulating signal as cos 2 pi fmt, then the AM signal is AC plus m of t into cos 2 pi fct. So AM signal with mathematical expression is, this is the expression. Finally, what we will get after analysis or simplification, you will get this as the equation, which includes three terms: cos omega ct plus k by 2 cos of omega c minus omega m into t plus k by 2 cos of omega c plus omega m into t. You can see that there are three terms. So these are the, as we are the mathematical expression in this is the time domain. In the frequency domain, what we will get is fc plus fm and fc minus fm when we simplify this one. So we can, this is what we are called in the frequency domain. We will call this one as the spectrum of the AM signal, which consists of carrier wave, lower sideband and upper sideband. So here the carrier wave, the amplitude A is equal to 1, and the amplitude of lower sideband is k by 2, and the amplitude of upper sideband is k by 2, which is got from this expression. Next, the AM power frequency spectrum is obtained by squaring the amplitudes. This is the total power for amplitude modulation, A square plus k square by 4 plus k square by 4, where A is equal to 1, the carrier amplitude, and this we are getting k square by 2. Therefore, total power for amplitude modulation is 1 plus k square by 2. So, coming to the modulation index of AM signal, modulation index is a measure of the extent to which a carrier voltage is varied by the modulating signal. When k is equal to 0, it is no modulation. When k is equal to 1, we are calling it as 100% modulation or perfect modulation. And when k is greater than 1, we are calling it as over modulation. And when k is less than 1, we are calling it as under modulation. So the modulation index formula is k is equal to amplitude of the message signal by amplitude of the carrier signal. So the modulation index of AM signal appears like this when it is 1. You can see the figure. So when the modulation index is less than 1, for example, it is 0.05, 50%, 0.05, then the under modulation is like this. So you can see here the over modulation. When the modulation index is greater than 1, we will be getting the distortion here. It leads to distortion. Thank you.